Hello, thank you for clicking on this video. This video, if you can see this, is about double angle, double angles in trigonometry. So first off, let's derive each formula because you should probably know how to derive it, not just what they are. My last video, I showed the compound angle formulas, and we'll use those to derive the double angle formulas. So, sine x plus x, because, one angle, you add this, not even just one angle, one number, you add that same number to itself, that's just double that number, right? Using the formula, we get sine x cos x plus cos x sine x. And, these two are literally the same thing. And then, like I just said, if you add one thing and add itself to that thing, it becomes double. So that means this is double sine x cos x, or 2 cos x sine x, doesn't matter. The next one is cos x plus x, right? The cos double angle formula, or formulas, as you will see. So of course, using the compound angle formula, we get cos sine sine, right? So it's cos x plus, no, not plus, minus sine x sine x. And as you can see here, if you just multiply cos x with itself, that just becomes cos squared x, and multiply sine by itself, that becomes sine squared x, right? But this isn't the only formula we have. Because we have, should I freaking write it? Whatever, I'll just write it like right here. We have this particular identity. Identities are literally the bane of my existence. How do people even come up with this, bro? Anyway, so you have this formula, this identity, right? If we rearrange things, we can get cos squared x equals 1 minus sine squared x. So if we apply that to here, we can also get cos 2x equals 1 minus sine squared x minus sine squared x. Now, there's two sine squared x's. Those are like terms. So those combine into 1 minus 2 sine squared x. But that's not all. This identity can also be rearranged into sine squared x equals 1 minus cos squared x. So cos 2x, instead of writing it there, how about I write it here? So that means cos 2x is also equal to cos squared x minus 1 minus cos squared x. We put the 1 minus cos squared x into a bracket because in the original expression, cos squared x minus sine squared x is negative, but according to this identity, 1 minus cos squared x is equal to positive sine squared x, which means we need to put it in the bracket and then distribute the negative. So now we get cos squared x minus 1 plus cos squared x. And then again, the combined like terms, that's 2 cos squared x minus 1. So there's three identities, not three identities, three formulas for the same thing. And then the final double angle formula is again tan. And that equals tan x plus tan x over 1 minus tan x times tan x, right? So now just do some basic math. The top right, tan x plus tan x, just equals 2 tan x. The bottom is 1 minus tan x multiplied by tan x, right? That just equals tan squared x, and there's your double angle formula for tan, right? So yeah. So now that we have these formulas, let's apply them. So the question here I have: determine the exact values of sine 2 theta, cos 2 theta, and tan 2 theta given tan theta. Okay, you know what? Let x be theta, because I'm not writing that shit every single time, bro. Anyway, tan x equals -7 over 24, and the restriction is that theta is in quadrant 2, right? So to determine the exact value, because it's easy to just do x minus you know x equals tan inverse whatever this fraction is, and then get a estimated answer. But the question asks for exact answer. So what we're gonna do is draw a triangle, right? My goodness, bro. Whatever. 7, -24. We find the hypotenuse. Really easy. C equals square root 49 plus 24 squared, right? Because a negative number squared is the same thing as the positive number squared, so it doesn't really matter. Oh my goodness. Right. Sorry. Right, so punch that into your calculator. We get C equals 25. So now with all three sides of the triangle, we can figure out the other primary ratios. And this will help us figure out the exact values of the double angles when we input them into like the formulas. So let's start off with sine 2x, right? So now we just plug in values that we just found. So so the formula is 2 times sine x times cos x, right? That's why we needed to find the primary ratios. So now the formula is just this. And then you can punch that into your calculator, right? Because, we live in the modern world. But if your mental math skills are better than mine, you could probably do this in your head. Yeah. But there's your answer. You should exercise your mental math skills. It makes you a more rounded person suited for life. Not like me. Right, so let's move on to the next one. Really it doesn't matter. Like when you apply the formula, it doesn't matter which formula you actually which version of the cos double angle formula you actually use. Uh so, let's just do something, one of the more simple ones, like 1 minus 2 sine squared x. Because, if you do cos squared minus sine squared, you'll get the same answer. It's just more effort because you have two ratios. So then punch this into your calculator. Right, and we get 527 over 625. And then, tan 2x is equal to 2 tan x over 1 minus that same fraction squared, right? So again, punch that into your calculator. You know what? Maybe this is why my math teacher loves identities so much, because we can't just solve it by just punching it into our calculator, bro. Identities are genuinely evil, man. Right, and now we get negative 336 over 527. So, that's just applying a formula really easy because someone's done the math for you, and it's basically a instruction manual. So beyond simply applying the formula, I showed you how we derive the formula. We're going to do that again to derive the formula for sine 3x in terms of cos x and sine x. So what is sine 3x actually? That's basically sine 2x plus x. And now we just apply the compound angle formulas along with the double angle formulas. So, this is basically equal to sine 2x cos x plus cos 2x sine x. Okay, so, split it up to make, well, not split it up, but like work on one part and then the other. Try not to work on the whole thing at once because then it'll, get messy and you might trip yourself up. So sine 2x is 2 sine x cos x, and then you multiply that by cos x, and that equals 2 sine x cos squared x. So that's, that part. This part, you might notice sine 2x here. Like earlier I said, it doesn't matter which version of sine of cos 2x you use. Here it does because the question specifically asks for in terms of cos x and sine x. So that means we're going to use the version of cos 2x with both ratios, which is cos squared minus sine squared. Right, so now you just do the multiplication or distribution as well. Right, so distribute sine x to open up these brackets. So now you get cos squared x sine x minus sine cubed, right? And then you can combine these like terms into 3 cos. Oh my goodness, what was I doing here? I'm so sorry. I am a little tired right now. It's a little late. That's why I'm kind of fumbling over my words very unprofessionally, but forgive me. But yeah, that's it. You know, Yay. It's, yeah. How about we try another one? So express tan 3x in terms of tan x. Again, we could split this up to tan 2x plus x. And then apply the compound angle formula. Right? So this, if I apply the double angle formula to tan 2x here, it'll get like really messy. So I'm just gonna split it up into two parts, the top and bottom. So the top is tan 2x plus tan x. Tan 2x is 2 tan x over 1 minus tan squared x. Add tan x. Actually, right. So now this is just, an addition question. So we're just gonna make an equivalent fraction for tan x by multiplying the numerator and denominator by 1 minus tan squared x, right? So now tan x, or oh no, I'll just do that, yeah. So now this is tan x 1 minus tan squared x, and you distribute that, that becomes maybe tan x minus tan cubed x. So now we can just add those together, which gets us tan 2x plus tan x minus tan cubed x over 1 minus tan squared x. Combine these like terms, and the top is 3 tan x minus tan cubed, oh my goodness, cubed x over 1 minus tan squared x. So that's just the top, right? The top of this. So now we're going to work on the bottom. The bottom is 1 minus tan 2x multiplied by tan x. Tan 2x, tan x. Right? So that's, oh my goodness, dude. Right? So now we have 1 minus, again, apply the double angle formula. Yeah. So now, remember your bed mass, right? Multiplication goes before subtraction. So we're going to multiply these two together, right? Tan x with this. So now we get 2 tan squared x over 1 minus tan squared x. And then, this is subtraction again. So 1 minus tan squared x, 1 minus tan squared x. Subtract those, we get 1 minus tan squared x minus 2 tan squared x over 1 minus tan squared x. Combine like terms, negative 1 minus 2, 1 minus 3 tan squared x over 1 minus tan squared x. How many times have I said tan squared x, bro? Another drinking game. Take a shot every time I said tan squared x. But anyway, so now we have the top and bottom, right? So, and because this original thing, right, is a division question, we're just gonna do this. We're just gonna set it up as a division question instead of, you know, in a fraction form, because that's really messy. Divided by 1 minus x 1 minus 3 tan squared x, right? And then obviously you multiply a fraction like this. I have to write it out first. Please be patient. Multiplied by 1 minus tan squared x, 1 minus 3 tan squared x. And then obviously this term, this thing, this term, whatever you call it properly. So this and this cancel out because, you know, they will divide and turn into 1. So now we have 3 tan x minus tan cubed x multiplied by 1 minus tan, what am I doing? Sorry, forgive me. Redo. So these cancel out, right? And then this becomes this. And that's the final answer. I made some mistakes at the end, but I'm not gonna re-record and write it all out again. So, yeah. I mean, I'm only human, bro. So, yeah. I hope you learned something from this video. Yeah. Have a good day.